Alright guys, so basically what I did is I picked 4 problems out of your textbook that are a decent mix of problems similar to ones that will be on your test. Again, these are not everything. Okay, I can't possibly do enough problems that include everything. At that point, if you need something specific, go back and look at one of the videos that's already been made on a particular topic, and that'll have more specific problems from each particular section. Okay, that would be the best idea there. But this will give you a kind of an idea. And my suggestion is, since they're all in your book and they're all odds, do the problems first, check the answers in the back of the book, and really you probably only need to watch the videos for ones that you didn't get correct. And then if you still don't get it after kind of watching my explanation of how I did it, then you probably got to just shoot me an email or come talk to me. Okay? So for this one, it's multiplication. First thing we need to do is make sure we factor everything, okay? Because our idea is that we want to cancel, but we can only cancel if we're written in factored form. So the first one is a basic one. We're going to be looking for numbers that multiply to negative 35 and add to 2. Those would be 7 and negative 5. So we get x plus 7, x minus 5. 6x cubed we can't factor. It's a monomial. It's one term. We can't factor single terms. 2x squared minus 6x. It kind of looks like a difference of squares, but there's no perfect squares, so that's a little weird. But always remember to check for greatest common factors. We can take out a greatest common factor of 2x. When we do that, we're left with x minus 3 in parentheses. And the bottom one on the right is very similar to the top left. We'll look for numbers that multiply to negative 21 and add to 4. Those would be 7 and negative 3. Now you can look for what cancels. X plus 7 certainly do. X minus 3 certainly do. And the question is whether 2x and 6x cubed, if we can do any simplifying there. The answer is yes, because 6x cubed is not followed by an addition or subtraction sign. Neither is 2x. Right now, on the top, these two are being multiplied, and on the bottom, well, we don't have anything else left, so I guess we can consider all of that multiplication. Okay, so we can't cancel the x minus 5 with anything, but 2 over 6 can cancel to 1 over 3. And x with x cubed can cancel to an x squared in the denominator. So we're left with x minus 5 in our numerator and 3x squared in our denominator. And that's all we can cancel. We can't cancel any of these x's because there's a subtraction after the x in the numerator, meaning we'd have to cancel x minus 5 as a whole. All right, that was the first one, multiplication one. So that's a good problem for looking at the, multiplication or division. Let's do a subtraction one. So we've got 5. This one's page 484, and it's number 51. And that would be 5x plus 17 over x squared plus 8x plus 7 minus 3 over x plus 7. Now, we do need to factor the denominator first, so I'm going to do that, and I'm just going to do it by erasing and then replacing. Okay, I'm doing that just to save some time and some room. Now here we're not allowed to multiply our numerators by everything. We're not trying to cancel out our denominators. We are trying to get a common denominator because we're just subtracting two fractions. This isn't an equation where we're solving for x. This is an expression that we're trying to simplify. So I'm going to multiply my second fraction by x plus 1 over x plus 1. And then in my second fraction, I'm going to distribute that 3. I'm going to leave my denominator in factored form, and we'll see why right towards the end of the problem. Now that I have a common denominator, I am allowed to subtract those numerators, but be careful. This is in parentheses, which doesn't really make a difference for the first one, but for the second one, it means I'm distributing that subtraction sign. So I'm doing 5x minus 3x, which is 2x, but I'm also doing 17 minus positive 3, which is 14. Now that I have it in one fraction, I should try to see if I can simplify that one fraction. Currently, I can't, okay, because I have addition and subtraction signs in there, and nothing's exactly the same. But if I take out a GCF of 2 for my numerator, now I've turned that into 2 times x plus 7, and I am free to cancel my x plus 7s, leaving me with 2 over x plus 1. Simplified really quite nicely. Next one is page 489, number 13. This one is a polynomial long division problem. So you put the denominator on the outside and the numerator on the inside. Now my original problem did not have this, but I'm going to put a plus 0x in there. And the reason is, it's not because I need 4 terms. Okay, it's got nothing to do with the number of terms. What I'm noticing though is I have an x cubed and an x squared, but I don't have an x. If I have an x cubed, I should also have an x squared and an x. If I were to start with x to the 4th, I should then also have an x cubed, an x squared, and an x. If I just start with x squared, I should also have an x. I gotta have all of the x's that go from my highest exponent on down. Okay, so since I didn't, and we'll see why kind of in the middle of the problem that was necessary. Okay, so first thing I'm doing is I'm dealing with these two terms. And I'm trying to figure out x times what gets me x cubed. Hopefully you figured out that that is x squared. We're going to put that up here. Then you are going to multiply the x squared, and I'm going to show some arrows here since you can't see me. I would normally not put these in the problem. But you're going to multiply the x squared by both of those. And you're going to write that below the first part of our problem. And then, just like in regular long division, we're going to subtract. When we subtract x cubed minus x cubed, we get 0. When we subtract 7x squared minus 5x squared, we get 2x squared. All we're going to do now is bring down our next term and then repeat the exact same process over again with the next set of terms. So we're still dealing with x, but now we're dealing with x and 2x squared. So we're trying to figure out x times what gets me 2x squared. The answer to that is 2x. Put that up top. Do the same thing. You're going to multiply 2x by both x and plus 5, and you will get 2x squared plus 10x. You're going to subtract again. Here is why we put the 0x in there. Because if you didn't have the 0x, what most people would probably incorrectly put is put a minus 49 here. And negative 49 and 10x are not like terms. So that would get looking really awkward. So that is exactly why we want to have the, the 0x in there. Okay, that's exactly why we put that 0x in there. Okay, so I'll put that back in. Now, we are going to subtract, and we get negative 10x. And we're going to bring down the next term. Do the same thing just one last time. And you're dealing still with the x, but this time with negative 10x. So x times what gets you negative 10x? The answer is negative 10. Multiply. Negative 10x minus 50. Here's another good reason to have this one in here. When you're subtracting here, be very careful. You're doing negative 49 minus negative 50. You get positive 1 there. Okay, and what you do with the remainder is you put that up top with a plus sign over what's in front. So that's my answer right there. X squared plus 2x minus 10 over, or plus 1 over x plus 5. Okay, last problem is a rather lengthy equation solve. I put probably one of these are mostly harder problems from your test, okay? Not directly from it, of course, but similar to ones that are on there. So here's the problem, and this is found on page 497, number 19. Okay, this time we are just simply trying to get rid of the denominators. So what we're going to do is we're going to multiply everything by x plus 6 and x minus 6, because we got to cancel both denominators. But we can't just pick which one we want to multiply by. If we're going to multiply by both of them, we have to multiply by both of them everywhere. So in the first fraction, the x plus 6's will cancel. In the second fraction, the x minus 6's will cancel. And over on the right side, nothing at all will cancel. I will distribute my 8 and get 8x minus 48. I will distribute my 8 in the second one, and I'll get 8x plus 48. And on the other side, I will FOIL x plus 6 and x minus 6. I don't need to multiply by 1 because it doesn't change anything. And I get x squared minus 6x plus 6x minus 36. I'm going to combine my like terms, and I get 16x. My 48s go away because they turn to 0. And x squared minus 36 on the other side. This is a quadratic, so I need to get it equal to 0. 0 equals x squared minus 16x minus 36. I'm guessing at this point most of you will probably use quadratic formula, which is great. Label your A, your B, and your C. And then rock on with the quadratic formula. I'm going to erase what I had up here. Oops, that's a green marker and far less helpful. Okay, I'm just going to erase that. And now I'm going to continue with quadratic formula. So the quadratic formula is this: negative b plus or minus square root of b squared minus 4ac all over 2a. Plug in your a, your b, and your c, and it should look like this. Now I'm applying the negative to negative b, so it was negative b, but my b was negative 16, so I make it positive 16. And I'm just doing b squared on my calculator ahead of time because, you know what, I don't want to have to show as many steps. That's really just my personal preference, okay? All over to a. Okay, and at this point we are just simplifying what's under the square root. When we do all that, we get 400. And 2 times 1 is 2. The square root of 400 is 20. And now, remember, you're just basically doing this problem twice. You're doing it once with plus, so 16 plus 20 is 36. Once with minus, 16 minus 20 is negative 4. Simplify, simplify. You get negative or positive 18 and negative 2 as answers. The only thing you have to make sure you check for at the end is to make sure none of the solutions were extraneous. The only way you will get an extraneous solution with these is if A, you did something wrong, so let's assume I didn't do that, which I didn't, or B, if one of your solutions would give you a 0 in your denominator. If we look back at the original problem, the only thing that would have given me a 0 in my denominator would have been a negative 6 or a 6. But since we don't have that, you know, we're all good, and both of those solutions are valid. Okay, so again, if any of those didn't go great, you know, you can let me know. Talk to me like, hey, I still watched it and I still don't quite get it. Be prepared to tell me exactly what part was an issue, and that might allow me to help you over email. But if not, you know, feel free to stop in before school and talk to me a little bit.